So now we understand that routers route traffic between subnets. We understand how a computer can determine if an IP address is on the same subnet or on a different subnet. But how does a computer determine how to reach other subnets? This is defined by the route table. So here I have a very simplified route table. In the first row we see that if the destination is 0.0.0.0 and the subnet mask is 0.0.0.0, this means any IP address. It's going to use a gateway. In this example, it's 192.168.114.1. This is going to be the default route or the default gateway on my subnet. But when traffic's being sent, it's going to look for the most specific match possible. So in the second line, we see a destination of 127.0.0.0 with an 8-bit subnet mask, or 255.0.0.0. The 127 network is always the local host. So 127.anything is going to be my local machine. So we see the gateway there is on link, meaning it does not need to go through a default route because it never leaves the physical computer. The third line, we see a destination of 192.168.114.0 with a 24-bit subnet mask. This is the subnet that the computer is currently located in. So again, it doesn't need to use a default route or the gateway. It can use on link. It just needs to send directly to that destination IP address. And then this fourth row is a special entry. This is for a broadcast. This is when we're going to send traffic that's destined for anything on my subnet. Broadcasts don't cross routers, so we do not need to send it to the default gateway. We just broadcast it out to the entire subnet. Let's open up a command prompt and let's actually look at a route on this computer. So we use that with the route command. If we type route, we get the instructions. There's really only one command you need to be familiar with, and that's route print. And that's going to print my route table. Now it's possible to add and remove items from the route, but generally speaking, as a developer, you're never going to need to do that. So let's scroll up a little bit, and here we have our IPv4 route table. So we see we're going to recognize a lot of these entries from my PowerPoint slide before. Here we have network destination of 0.0.0 and net mask of 0.0.0. So it's going to go through my gateway, 10.0.1.1. On the interface, 10.0.1.11. That's my current IP address. This last entry is the metric. It's going to go for the lowest metric possible. It's possible to have two different default gateways, and it will go through the lowest metric, the lowest cost possible. And we can see there's going to be other entries in here that we'll be familiar with. 10.0.1.0 with the 24-bit subnet masks on link. That's my local computer. And different representations of the same thing here. We also have an IPv6 route table, which has become a lot more important to us as we start to have IPv6 connectivity. So how does it know the gateway is 10.0.1.1? That comes through the network configuration. If I do an ipconfig, we'll see that one of the things that's defined is the default gateway. So any traffic that's destined for another network goes through my default gateway, which is 10.0.1.1 in this case.